Assalamualaikum and hello guys. My name is Muhammad Azmi Ikmal bin Ahmad Smawi. I am from section 7. The topic given to me is plastic for implants. So, what is plastic for implants? Plastic for implants are device or tissue that placed in the human body, externally or internally. This used to replace missing body parts in the form of prosthetics. The common functions are basically medication delivery, body function monitoring, and some support mechanism for organs and tissue growth. And also, it can be reproduced using skin, bone, or other body tissue, as well as metals, plastic, and ceramics, as long as it is biocompatible. The common use for implants are component replacement for living, such as hip replacement, function restoration, which is help you to hear a lot better if you have hearing problems. It is also used in medical device for surgical procedure, and also biocompatible and harmonious interaction with the body. So these are the implant consideration. First is biocompatibility, which is you need to make sure that the material is non-carcinogenic, non-toxic, and many more, so that it will not harm to our body. Next is strong physical characteristics: strength, toughness, elasticity, corrosion resistant, and wear resistant, so that it will last longer. Next is sterilizability, which is mean that the material can be sterilized so that it will prevent from radiation or dry heat, and also autoclaving. And the last one is the manufacturability, which is mean it can be produced by machine, so that it will produce lot more. Next is example of material that being used in implant, such as ultra high molecular weight polyethylene for joint replacement bearing, polypropylene for metacarpopylene joints, and others. One of the example of the application is spinal reconstruction. So first step, a high quality image through a CT scan, so that we can construct a accurate 3D CAD model, and then the 3D CAD model is being analyzed by the surgeon, so that he or she can identify the structures that need to be removed or reconstructed. And then they utilize a CAD software to design the defects that needs reconstruction, and then they analyze of force and loads and simulation, so that it fits the spinal correctly. So next is a cochlear implant. A cochlear implant, usually we can see some of people with severe hearing loss, where it is because cochlear implant is help in making the sound louder. How it works? It works by stimulating the cochlear nerve, and it consists of internal and external components. The cochlear implant converts sound into electrical impulse, while hearing aid act as an amplifier to make the sound louder. The polymer that we use is Teflon. So the Teflon is to insulate the wire between implant body and electrode contact due to its thermal and chemical stability. Next application is angioplasty. Angioplasty is basically a procedure to open the blocked coronary arteries. These implants will help a patient with a low blood flow by inserting a long thin tube inside the blood vessel and guide it to the plug, and then the catheter is inflated, which press the clots on the side wall of the arteries and allow more room for blood flow. Catheter used for angioplasty is normally they have 3 layers. So for the outer layer is nylon elastomer band for curve retention, and middle layer stainless steel because so it can be moved easily, and for the inner layer is Teflon for lubricity. Next example of application is for bone and joint replacement. For example, if for the hip joint with osteoarthritis, we can replace these joints by using prosthetics that are made of titanium, ceramic, and polyethylene. Next is for a broken right clavicle bone. It is being replaced by carbon clavicle so that it can receive more shocks absorption, higher impact, and it also have more tensile strength. And for the last application is 3D bioprinting. 3D bioprinting is usually used to construct a tissue. It is by construct scaffold for tissue growth due to its ability to print several materials. By using bioprinting, functional organ on a chip will allow fluid flow, gas exchange, and waste elimination. So this is a different types of 3D bioprinting technologies. And also 3D bioprinting used to replicate some parts such as natural tissues, ligaments, bone and or joints, and blood vessels. Lastly, the conclusion. It shows that extensive research into polymer technology has allowed them to match the capability of metal implants. Next, biomedical applications, they utilize of plastic implants because it is chemical resistant, mechanical properties, and most importantly, biocompatible with the human body. So, as the world move to more technology, as the development of biomaterials are highly sustainable because they are more eco-friendly with added aesthetic value, and it also will help in lowering the cost. In conclusion, the development of plastic implants has benefits the whole biomedical industry. That's all from me. Thank you.